Okay guys, let's try and sort out this sum. A circular race course track has a radius of 500 meters and is banked to 10 degree if the coefficient of friction between tires of vehicle and the road surface is 0.25. Alright, find Vmax to avoid slipping and velocity to avoid wear and tear of tires. G given is 9.8 meter per second square. Alright, this numerical is just to make you understand the application of formula. First thing, tan wala formula. Okay, second thing is how do we use log for such numericals. Alright, that's the main contention of my making use of this numerical. Alright, so what do? We just substitute the values. Now Vmax is equal to R is radius is 500 meters, G is 9.8 meters per second square, and then we have got to write mu s given is 0.25 plus tan of 10 degree. Alright, and this is divided by 1 minus 0.25 tan 10 degree. Alright, this entire stuff is in root. Alright, now when we intend to find velocity to avoid wear and tear of tires, that is actually safe velocity, which is equal to Rg tan theta root. Alright, so we just substitute that. So it would be R we know is 500, G again is 9.8, and tan of 10 degree, right? So just check out how do we get this by log and how do we get this by log. Alright, which is following. Alright, okay. Okay, so anti-log, half, log of 500, log of 9.8, log of this is done here. Tan of 10 degree we already had found out, it was 0.1763. So okay, let's proceed with this. 50, we know point is over here, so we shifted 2 decimals this side, so it would be, as per my rule, it would be 2 point. The characteristic would be 2 point. Then we have got to see 50 in 0. Let's check it out over here. So it is 50 in 0, which is 6990. So it is 6990 plus, now it's already there at the unit space, so a characteristic would be 0, and 998 we have got to check. So let's check out for 98. 98 is 9912. So it is 0.9912 plus log of, we know it is 0.25 plus tan 10 degree we had seen yesterday also. Let's check it out again. Natural tan, we have got to check it out in this. It's here 0.1763, so it is plus 0.1763, 0.1763. Then in denominator also 1 minus 0.25 into 0.1763, that is also tan 10 degree. Alright, done. So this would be anti-log later on, half of 2.6990, we'll add it later, 69 we could have added it now, plus 0.9912 plus log of, now if we calculate this, what we end up with is, 0.4263 in the numerator, and in the denominator it would be 0.9559. Okay, so then what we do is anti-log half of, if we add these two up, it would be 3.6902 plus log of, this would be, on calculation what we end up with is 0.4460. Alright, so we have got to get log of this. So anti log half 3.6902 plus log of 0. Now it is 0 point, so we have got to shift it. We have got to shift it one digit here, so it would be bar 1, since we are shifting it this side, and one digit, so bar 1. 0.4460 we have got to see in log 44 in 60. So we have got to see 44 in 60, so 6493. It comes to 0.6493. All right, so this comes to anti half. Now see, bar 1 and this comes to, this is minus 1, we can assume it as 2 point, when we add it up it comes to 2.6902 plus we can put it as 0.6493. okay, and obviously half I missed out, so this would be anti half of what, half of 3.3395 if we add this up. All right, so this becomes, now we have got to check, for anti log half of this value. Half of this value comes to be 1.6698. 1.6698, and we have got to check anti of this. We have got to check for, so it is 1.6698. we have got to check for 0.6698 in anti log. So it's over here 0.669 and 8. All right, so that comes to 46. It comes to 4676, and as per my rule I told that blindly put point over here and then whatever is the value over here, put it here. So your answer becomes 46.76. so this is your answer, and it is meters per second. Okay.